Good afternoon, everyone. My name is Stan Kitchen. I'm a retired research botanist with the Forest Service Rocky Mountain Research Station. I'm pleased to be able to meet with you today. I apologize about a computer problem and my face won't show during this presentation. That might be a good thing for some of you. 2 years ago, I spoke of historical fire regimes for multiple sites in southern Utah. I presented at that time evidence that reveals temporal and spatial patterns of historical fire variability for common forest and woodland community types. In review, low severity surface fire causes localized mortality of cambial cells for many tree species. The cambium is a thin layer of living cells located between the bark and the sapwood. Within a few years, the protective bark sloughs off the damaged tissue, leaving affected trees susceptible to repeated injury. Consequently, it is common for trees of some species to have recorded in their annual growth rings many fire events across several decades. Careful examination of the placement of these injuries within tree ring chronologies reveals the timing of past fires with annual and often seasonal accuracy. Combining fire records from fire-scarred snags, logs, stumps, and living trees enables the examination of fire regime temporal patterns covering time periods of a few to several centuries. Spatial patterns, including the size and shape of burn areas in relation to topography, is inferred from the collective analysis of burn records taken from numerous trees scattered across the landscape. So what were my conclusions? First, for dry mixed conifer, ponderosa pine, aspen, and gamble oak vegetation types, frequent non-lethal surface fire was the norm, with infrequent high-severity fire restricted to cooler and wetter aspects. By frequent, I mean that the average time between fires varied from about 5 to 35 years, depending on the landscape position and vegetation type. These generalizations hold true across elevational gradients and persisted until the mid-1800s, when tree ring-based and historical records indicate that surface fire either became much less frequent or simply disappeared. In this table, I draw your attention only to the different vegetation types and the mean fire intervals, those two columns, and point out that regardless of the vegetation type, mean fire interval ranged between 5 and 35 years for numerous different sites. Second, most historical fires burned relatively small areas, less than 100 acres, suggesting that the quantity and continuity of fuels needed for fire spread were limited by previous fires. I also observed that big fire years occurred much less frequent, minimum of one and often several decades apart. In these, annual area burned was much larger, hundreds to thousands of acres. Whether this was the result of single large fires or caused by multiple ignitions in a single year, the evidence typically suggests that burning occurred for many weeks to months during the fire season. Third, fire seasonality was not well correlated with periods of highest lightning activity. This was especially true for small fires, which clustered either early or late in the growing season, both of which are off-peak for lightning. From this and other evidence, I concluded that human ignitions clearly played a major role in regulating long-term fire regimes, and thus an equally important role in shaping vegetation composition and structure, and did so for many forest and woodland and potentially shrub and grassland types, at least until the mid-1800s, when Euro-American settlement disrupted indigenous burning practices. Later, the implementation of modern fire suppression practices was effective in extending the post-settlement fire exclusion period for several decades. I ended by suggesting that, consistent with patterns observed across Western North America and indeed globally for thousands of years, hunter-gatherer and dispersed semi-agrarian cultures in what is now southern Utah used fire to actively manage environments to achieve specific outcomes. Now then, over the last 4 decades, we have seen two important developments related to fire on Western North American landscapes. First, in spite of expansive resource investments, fires have become larger, more severe and damaging, and harder to suppress relative to those of the preceding 6+ decades. Most agree that this shift is due to a host of factors, chief of which is the accumulation of both living and dead fuels due to the long absence of fire. Second, research has revealed how different fire regimes and corresponding vegetation structures are today in comparison to those of just 150 years ago. These two realities intersect in a continental scale study published in February of this year in the journal Nature Communications. This study took up the question, quote, whether and to what degree contemporary fire regimes are still departed from historical fire regimes, end quote. While authors were quick to point out that, quote, unprecedented contemporary fire severity is driving forest loss in many ecosystems and adversely impacting human lives, infrastructure, and water supplies, results indicate, despite increasing area burned in recent decades, a widespread fire deficit persists across a range of forest types. And finally, recent years with exceptionally high area burned are not unprecedented when considering the multi-century perspective, end quote. Or in layman's terms, we haven't caught up to the past. So in the remainder of my time, I will outline some aspects of the job of fire manager as practiced for at least centuries in Western North America before the mid-1800s. I will compare this paradigm with its modern counterpart, with hopes of uncovering insights useful for improving our capacity to utilize natural and human-set fire as we work to reduce the fire deficit, improve safety, and build forest resiliency. One disclaimer, my descriptions represent my best effort to interpret the subject and almost certainly contain inaccuracies. That said, I propose that this exercise may still be helpful. To clarify, I limit my discussion to the intentional use of fire, recognizing that opportunity for accidental or escape fires must have been ever present. First, consider whether the authority to decide when and where to light fire was shared generally among all members of a group or concentrated in one or a few individuals. I can conceive of a variety of problems that could emerge if this authority were decentralized, with safety among the major issues. Instead, I believe that this authority and the corresponding responsibility must have been centralized, perhaps in the same way that the right to perform many rituals was invested in one or more spiritual leaders. Indeed, the practice of applying fire to Mother Earth likely had as much spiritual as practical significance, and very well might have required approval from ancestors or other spiritual authorities. In contrast, on public lands at least, decision authority and responsibility today rest with the line officer. She or he must be familiar with the laws and regulations that govern fire use and the planning process, such as the National Environmental Protection Act, or NEPA, that must be completed before lighting the first match. To complete this pre-work, officers today rely heavily on specialists that analyze potential impacts of the decisions to burn or not burn, and if to burn, the when and where, in order to weigh the risks and potential benefits for a host of interests that are often in conflict, including wildlife, watershed function, timber, recreation, private property, archaeological resources, wilderness values, livestock grazing, sensitive species, airshed quality, utilities, infrastructure, and so on. The focus is on safety first and secondarily on ecological or resource outcomes, and rightly so. The primary focus for indigenous fire managers was on the practical benefits, although safety had to be a consideration. Immediate benefits might be realized such as fireproofing a campsite, clearing a trailway, driving game, insect collection, or pest management. Benefits would be delayed and require advanced planning when fire was used to kill trees for firewood, improve the quantity and/or quality of plant growth, think berries, roots, seeds, stems for arrows, fibers for weaving, or to green up or freshen grasses to attract game animals. Today, potential impacts on the airshed are a major consideration. Poor atmospheric conditions may delay ignition even when other factors are optimal. I imagine the smoke management in the past was simple. If you wanted to breathe, stay upwind. Timing of ignition would have been critical in the past and remains so today. It is the best means for controlling the duration and spread of the burn. Cool season burns, spring and fall, with low temperatures, higher humidity, and little or no wind facilitate slow burning in smaller burn areas. Midsummer ignitions are at greatest risk of severe burns and potentially adverse fire effects today, and were likely recognized as such in the past. Effective public relations are vital to successful implementation of burning programs in the modern world. The issue is one of managing expectations. Open, honest communication before, during, and after managed fire reassures the general public and reduces pushback from concerned resource advocates. Although the consequences of mistakes vary, a good manager today documents the decisions process carefully to protect his or her job and to apply lessons learned in future situations. What about the past? Was there a parallel need to manage expectations for the indigenous fire manager? We might suppose that if an attempt to burn was unsuccessful, one could always try again. However, repeated failures might risk a challenge to one's credibility as the one chosen to wield the power of fire. On the other hand, there would have also been risk to burning too much or too hot. Such burn events could have risked lives or destroyed needed resources. Overall, lower fuel loads would have reduced this risk, and that itself could have provided sufficient motivation to not allow too much time to pass without fire, even when other specific purposes for burning were lacking. And we can assume that having a suppression team mobilized and ready to assist was not an option. So what, if any, of this is helpful for improving how we manage fire today? I offer 4 suggestions for consideration. First, it is time to change the paradigm from one of fire as an evil force that must be stopped at all costs to one of fire as a tool, one that requires skill to manage properly, but still a useful, even essential tool. The decision to use this tool is no more risk-laden than is the one to refuse it. Second, long-ignored indigenous knowledge regarding traditional burning practices has much to offer and should be incorporated with science-based principles for applying fire on modern landscapes. It is an encouraging sign to see modern examples of this kind of merged management practiced by indigenous peoples alone and in collaboration with traditional fire managers in disparate parts of North America and elsewhere in the world. More is needed. Third, a decision to use fire is a long-term commitment, not a one-off fix-all. This commitment must be infused into practices and policies that last far beyond the tenure of any one manager. Such a commitment must emphasize learning from mistakes rather than punishment. Fourth, we must do better in communicating the trade-offs, impacts, and benefits of burning, both short and long-term. Likewise, we must clearly identify the impacts and risks of choosing not to burn. Finally, I suggest that the choice to burn or not is in fact a false choice. For the last 4 decades have made it clear, one way or another, burning will happen, almost everywhere. The real choice is whether the next fire will be on terms of our choosing, or will it be left to chance. Thank you for your time.